Hey everybody, welcome to day 3 of lesson 13. So we're going to continue on with our work on percents, right? So I just want to kind of point this to you. Can you see the cursor there? So what we're going to be talking about is percent error today instead of percent increase and decrease. And we're going to focus on reasoning abstractly and quantitatively today in terms of math practices. I'd love to have you take just a little bit of a look at this sign. I know we don't usually look at that, but modeling with mathematics is not just like using a bar model, using a number line, that type of thing. It also involves thinking about math, thinking about the relationships between numbers, estimating, right? Remember, always estimate first. It's kind of like thinking before you act. You know, it's a good practice in life, but it's also a really good practice in math. Think about the problem before you try to solve it, and think about, what's a reasonable answer, right? You're much more likely to get the correct answer if you do. All right, hey, let's move on to our warm-up. Oh, yeah, I forgot about this. All right, this first, all right, don't forget, you need to hand your work in, right? This is how we're keeping people accountable. This is how we know that you're paying attention to the video, all right? Now, let's move on to the warm-up. All right, if you've never heard of an ST mystery, then these are kind of cool. All right, if you have heard of one, just go ahead and get going because I've got all of the clues right here. But those of you who aren't sure what that is, basically ST mysteries involve figuring out how many objects are in the picture. So in this case, we're going to be figuring out how many triangular prisms are in that glass, right? So first thing I always do is just kind of take a look at the picture and try to ballpark it just a little bit. So I'm guessing, well, it's probably more than 10, but probably less than, say, 80. Right, and then you look at the clues, and you use the clues to help narrow down your answer. So it says the number's less than 70. Right? I was thinking maybe in the 60s, maybe in the 50s, right? 50s, 60s. I'm going to go down to clue 2 now. It says the answer does not include the digits 1, 3, or 5. All right, I know it's not in the 50s then because that's a 5. So then maybe it's in the 60s, right? Anyway, I'd like you to just pause the video, go through these clues yourself and see if you can guess the number. Okay, then start the video again when you're ready to hear the answer. All right, there's the answer. All right, it's right below my picture there. So the correct answer is 47. So I was thinking in the 60s, so I had that too high. I'm hoping some of you got that correct. If you got it correct, let me know. Like, yeah, I got this right. I make sure you were clear about your work and your thinking so I can see, yeah, you were involved in the warm-up. I was thinking 61, but that would have fit all the clues, but I probably needed to do a better job looking at the actual glass. All right. Anyway, we'll have some more ST mysteries, and we'll do some that are a little bit more challenging in the future. All right, let's move on to the actual lesson here. Again, this should look familiar to you. I want you to read along with me while I read out loud. So it says, Leo estimates that a package weighs 24 pounds. The postal clerk weighs it and finds it weighs 20. What is the percent error in Leo's estimate? All right, if you look at the bottom of this slide, you can see that I actually included the ratio that you can use. So you want to know the amount of error. It doesn't matter in this case whether it's higher or lower. That would matter if we were looking at percent error of increase or was it a percent error in decrease, and sometimes we do that, but in this case we're just looking for the percent error. All right, so you take the amount of error, and it's over the actual amount. Remember, fractions are division problems, so I might be thinking to myself amount of error divided by actual amount, and then change that to a percent. All right, so pause the video. I want you to answer the 3 questions at the top. Make sure you do that, right? And then see if you can solve the problem, all right? When you're ready, get the video going again. All right, so here we've got a couple of models that give the answer, and today I'd like to actually start by looking at the equation piece, all right? Right down in the left corner. rather than starting with the bar model. The reason is because I gave you the equation for finding the percent error. So it was the error divided by the actual amount. So in this case, it's 4 divided by 20. All right, and you can see that they are using a little algebra here that equals x over 100. If you are trying to figure that out, I would probably do this. 20 times what gives me 100? 20 times 5. So 4 times 5 is 20. So if it's 20 hundredths, then the error is 20% error. All right. If you look down at the bottom of that, you can also just do 4 divided by 20. And remember, I'm allowing calculators on this, so that would give you 0.2 or 2/10. Right? If you're changing that to a percent, that's 20%. Because remember, percent's out of 100, so 2/10 is the same as 20 hundredths. It's a 20% error. Right now, what I like about the bar model is it shows what's going on. Right, so I took the 20 and the 100% and put those across the top. Right, that was the actual amount, so that's the full amount. And then we're trying to compare the mistake with the full amount. So the mistake was 4, so I'm like, oh, I can split 20 up into groups of 4, right? Think fair sharing, right? I want to split 20 up into groups of 4. So that's actually quotative division, right? How many groups rather than partitive. You want to do something a little bit interesting, look up the difference between partitive and quotative division. Anyway, back to this. So there are 5 groups of 4. So that's the important thing here. So then I know 4 is actually 1/5 of 20. So again, if you look down at the bottom, 4 out of 20 is the same as 20 out of 100 because I need 5 of those 20s. You could also think about it as 1/5, and that equals 20%. All right, I'm hoping you can kind of see how the bar model and the equation work together. They're both representing the same thing, but I hope you can see how they're related. All right, let's move along. All right, here's the next thing I'd like you to do. All right, and this is a page from your instructional book. I'd like you to number 9 through 14, and I'd like you to answer each of these questions carefully. Think about it. Questions 9 through 12 really relate to the work that we just did. All right, so if you need to rewind the video, go ahead and do that, or if you need to go back and look at the previous slide, go ahead and do that. 13 and 14, you can see I put the ratio down there for you. Use that to help you, all right? So pause the video, take your time, think about these things, get these questions done, and then when you're ready to go over it, hit the play button. All right, so what I'd like you to do is I'd like you to grade your own, particularly 9 through 12. I'm not even going to go over those. I want you to look at the answers that were in the teacher's text. If there's anything there that does not make sense to you, please circle that problem, or if you're doing this on a Google Doc, highlight it or something to let us know that you don't understand it. All right, but let's take a look at 13 and 14. Okay, you can see what I did beside each is I put the ratio for finding the percent error. So the amount of error divided by the actual amount. So Emma was off in her ribbon calculation by 4 centimeters. So that's going to be my numerator, 4. And then I want to divide that by the actual amount, which is 80. So if you look at the equation I have right below me, you can see that it is 4 over 80. I reduced that to 1 over 20 because I thought that was an easier way to then switch it over to a percent, right? Which, again, you can see is 5 over 100, right? And that actually is going to become 5%, right? That makes sense, right? 5 out of 100, 5%. Or you can look over there. All right, I think that that's the more efficient method. I just did 4 divided by 80 in my calculator. I got 0.05, which is 5 hundredths, and that's 5%. Okay. If you look at Christopher's problem in 14, he was off by 5 minutes in his estimate about doing his math homework. Since the actual time was 25 minutes, I just made a ratio, fraction, division problem. It's all of those things. So it's 5 over 25, or 5/25, I reduced that to 1/5. You don't have to do that though. The important thing is that it becomes 20 over 100 or 20 hundredths, which is 20%. Or again, the really fast, efficient method, 5 divided by 25 in your calculator gives you 0.22 tenths, which is really the same as 20 hundredths, which is 20%. Remember, if you have the decimal, you can move the decimal point 2 places to the right, right? So I'm going left because this is backwards, 2 places to the right, and that will give you the percent. All right, let's move on to the last slide. All right, this slide is just a reminder that you need to hand in your homework. All right, so make sure you do that however it is your teacher wants you to do that, and we'll be grading this for participation. All right, hey, thanks very much, and I hope you have a good day.